Significant figures, or significant digits, sometimes referred to as Sig Figs, are the digits in a number that tell the precision of the device used to measure the quantity. You see, in chemistry or any science, a number is not just a number, it's a measurement. Even though you see it in your book or in a problem, it was actually a measurement that somebody made. And we need to tell how precise that measurement was using that particular instrument. I'm going to show you how the precision of the instrument can tell us how many significant figures are in our number. In this bar, there is only one measurement, and that's a 1. I'm going to estimate that this measurement is around 0.5. In this next ruler, we now have more graduations on it, and it gives us more precision, or more accurate measurement. So if I look at this, I know it's not 5 now. And I know it's not 4. It's somewhere between 4 and 5. And I'm going to guess around 4.7. Notice now we have 2 digits in our answer, 4 and the 7. So we estimated that 7. The 4 we know, the 7 we estimated. Now we're getting more and more graduations on our measuring device. So I know now that it's not only 45 or 46 or 47, it's somewhere between 46 and 47 and really close to the 47. So I'm going to guess around 46.9. Notice that each time that we went through this, we got more and more precise in our measurements. Now we don't always have the measuring tool in front of us. Sometimes the number's already written down on paper. So we need to tell how many significant figures are in a number. The way I like to teach it is the Atlantic-Pacific rule. In the Atlantic-Pacific rule, you need to know that non-zero integers are always significant. That's your 1 through 9. The only one that we need to worry about is 0, of whether or not it is significant or not. Sometimes zeros are just placeholders. If the decimal point is absent, we start on the right side where the Atlantic Ocean is, and we work our way going left. If the decimal point is present, we start on the Pacific side, and we work our way to the right. Let's go through a few examples. The first example is 0.0045. Now the decimal point is present, so we're going to start on the left side, or the Pacific Ocean side, and work our way over to the right. You do not count any zeros until you come to a non-zero. So those first 3 zeros come before the 4, so we do not count them. So the only 2 significant figures here are the 4 and the 5, giving this number 2 significant figures. In this next number, the decimal point is absent, so we're going to start on the right and work our way left. The first number we come to is 5, a non-zero, so that number and every number to the left of it is significant. So all 3, the 1, the 0, and the 5 are significant, so this tells us that it has 3 sig figs. The next number, 1600, without a decimal point, which means we would start on the Atlantic side because it is absent, and we're going to work our way left. Notice we get to 2 zeros before we get to the 6. So those 2 zeros are not significant, and the only 2 numbers that are significant are the 1 and the 6. Hence giving this number 2 sig figs. In the next number, which looks almost identical to the one above it, except that this has a decimal point. So instead of starting on the right side and working to the left, we start on the left side and work towards the right. And now we come to a number 1 first, which makes everything after that significant. All 4 are significant. So this number has 4 sig figs. Sometimes we need to round with concern to sig figs. And what I'm going to do in all of these 4 situations is I'm going to round all of these to only have 3 sig figs. In the first example, there are 7 significant figures in that number. I only wanted to have 3. So what you do in this situation is you start on the left and you start counting the number of significant figures. There's our first 3, right there. So when we look at those 3 significant figures, you look at the very next one after the last significant figure on the right, and you look to see if that number is 5 or greater. If it is, you must round the last significant figure up. So in this case, I'm going to write it as 2,460,000. And you'll notice if we start to the right, because the decimal point is absent, you'll notice we only have 3 significant figures. In this next example, we're going to start from the left and go to our first significant digit. That would be the 4, the 5, and the 6. Those are our first 3 significant digits. And if we look to the right of the 6, the 7 is 5 or greater, so we have to round it up. So this number becomes 0.0457. And notice, since the decimal point is present, we would start on the left side and work our way to the right, making those 2 zeros at the beginning not significant, and only the 4, 5, and 7 being our 3 significant figures. The next number, we're going to round to 3 significant figures, so we start at the left and we count our first 3 significant figures, which is 1.04. Notice the 3 right after the 4 is not higher than 5, so we just keep it as 1.04. No need for rounding that 4 up. The next example, we have 0.000. Notice the decimal point is present, so those are not significant. So the first 3 significant numbers are 8, 2, and 6. Look at the right of the 6. There's a 5. We're going to round that 6 up. So our answer becomes 0.000827. Notice that it only has 3 significant figures. Here are some tricky ones that can throw some people off. Let's say I was going to round these to 3 significant figures. If I have 149.8, the first 3 significant digits are the 149, and I would have to round that up to 150. But the decimal point is not present in 150, so we would start on the right side and work our way to the left. Well, that makes that 0 insignificant and only has 1 and 5 being the significant digits, which only gives us 2. So in order to make this have 3 significant digits, we need to make sure we put the decimal point. And now we start at the left and work our way to the right, making that 0 significant. The next one is even trickier still. We have 1500 and we want to round that to 3 Sig Figs. Well, we make that 1, 5, and the 0, and that gives us only 2 Sig Figs there, and it's not even close to 1500. It has to be close to 1500. So the way we get around this is to put it in scientific notation. And what we do there is we write 1.50 times 10 to the third. The 1.50 and anything to the left of the times 10 in scientific notation is significant. So the 1, the 5, and the 0 are significant because the decimal point's present and we start at the left and work our way to the right.